Okay, let's say we had this example, and this is another example of combined stresses that we see in civil all the time, civil type applications all the time. And this would be a little like footing wall system, and the footing is subjected to 100 kips of force, compression force that comes through the column into the footing, okay? And then the footing is also subjected to 50 foot kips of bending moment, and the 50 foot kips of bending moment might be coming from a wind load, or it might be coming from soil pressure. It could be coming from a lot of different places, lateral loading that creates a bending. And what this means is, like, you can imagine this footing, the 100 kips wants to push this footing down into the ground, but what the moment wants to do is it wants to rotate the footing. Okay, so it's really bending the footing almost like a beam, but it's bending the footing down into the soil over here on the front side and actually wanting to lift it up on the back side. Okay, does that make sense? So very common application of combined stresses is this type of an arrangement. Okay? So there's a couple things I like to do. I mean, once you've said, yeah, hey, I've got a combined stress situation, I really like, and I think it's simpler for everybody, if you just go ahead and sort of list out the different things that you need to know. So, you know, P over A, so I need P, I need A, MC over I, so I need M, C, and I. This is sort of a plan view of the footing. I mean, the footing's 5 feet length, maybe 4 feet if you want to call it width. All right, and really I'm just interested in sort of the footprint of the footing where it makes contact with the soil. Okay? So, anyway, what's my load P on my footing? A 100. And that's 100, that's actually a compression, so I'm going to say minus 100 kips. And again there, that's purely arbitrary, that's sort of just sign convention, but we did say, hey, there's a difference between tension and compression. And when we have compression, I'm going to call it a negative. All right? What's the area of the footing? And really this is like the footprint of the footing as it makes contact with the soil. 20 square feet. Okay? What's the moment that the footing is subjected to? $50 foot kips, right? All right, so 50 foot kips. All right, what's the C distance that I have? C distance is from the neutral axis, the axis of bending, to the outside edge of the element. In this case, the outside edge of the footing. 2.5, that's right. So you got to establish, you know, where the axis of bending is. That'll be for us the centroidal axis. And so the C distance, if you're looking for maximums, which again typically we are, unless somebody tells us otherwise, it's going to be the distance from there to the outside edge. So in this case, 2.5 feet. All right? So if we've got that axis, what's the moment of inertia about that axis? How are you going to find moment of inertia? It's a standard shape, right? It's a rectangle, correct? So we go back to, and you can sort of see where all this is looped into the stuff that we've had before. For a rectangle, it's 1/12 base times height cubed. Which side's the base here? No, the base is the 4-foot side. The base is always the side parallel to the axis that you're looking at. Okay, so 4 feet. The other side, 5 feet, is the height, and so that gets cubed. So let's see, what would that be? That'd be 5 times 5 times 5. That's 125 divided by 3. That's 125 divided by 3. Okay, 41.67. All right. Okay. So we got them all listed out. We just got to get it straight now, right? So what I like to do at this point is I like to just calculate what we got here. I know I'm going to have to get P over A, right? Well, I got it. P over A is minus 100 kips divided by 20 square feet. So P over A, no matter where I'm looking at, P over A is going to be, in this case, minus 5 kips per foot, square foot, excuse me. All right, minus means this is a compression stress. What about bending? What about MC over I? MC over I, again, pay attention to units just in case, you know, you need to do anything. But moment, 50 foot kips, C, 2.5 feet, and I, 41.67 feet to the fourth. So what do I come up with there? What do you come up with? 2.43. 2.43? Just 2.3. And again, if you look, our units were fine because we were dealing with feet and then feet to fourth on the bottom, so we're all good. You got feet squared on the top divided by feet to the fourth, so you got kips per square foot. So, hey, that's good because we had kips per square foot up there. All right? My question here to you is, where is that 2.3 kips per square foot a compression, and where is it a tension? Now, here's where you got to think about what's actually going on. Where is it a compression type? This is a bending stress. 2.3 kips per square foot is bending stress. But a bending stress has a compression side and a tension side. Which side is the compression side? Which side? The front side. Because, yeah, because see, I'm rotating it this way, so this front part is going down into the soil. So the front is actually a negative 2.3 kips per square foot, and the rear is positive 2.3 kips per square foot. Okay? What I like to do is I like to create a little table just to keep everything straight. And this table can change depending upon, you know, how, you know, your problem's actually situated. But what I would do is, I know I got a front and a rear side of the footing. I know I've got P over A. I know I've got MC over I. P over A is the same whether I'm at the front of the footing, the back of the footing, or any place in between. It's minus 5 kips per square foot. The front of the footing, you just told me, is a negative 2.3 kips per square foot. The rear of the footing is positive 2.3 kips per square foot. So my combined stress is simply this. In the front, that's minus 7.3 kips per square foot. And in the rear of the footing, that's negative 2.7 kips per square foot. All right? So what this means is the pressure underneath my footing is all compression. It just happens that in the front part of the footing, it's 7.3 kips per square foot, compression stress, and in the rear part of the footing, it's 2.7 kips per square foot.